Hello to everyone and welcome to our webinar. My name is Meeta Bhattacharya and I'm the Product Marketing Manager here at Kubernetes, and I'm also the moderator of this webinar. The topic of the discussion today, as we know, is separation of orchestration and computation in KubeEdge, and our speaker is Harshita Sharma. Harshita is a Kubernetes and Golang developer here at Kubernetes, working on multi-cluster management and automation. She is an open source enthusiast and has an interest in developer advocacy. She spoke about the KubeEdge at Kubernetes on Edge Day at KubeCon Valencia this year. And before I hand over this session to Harshita, I just want to go over a few things. During the course of this session, if you have any questions, please feel free to write to us through the Q&A section at the bottom of your screen. And at the end of the session, we'll be able to take all the questions together and answer as many as we can. So with that, I hope you all enjoy this session, and Harshita, over to you. Harshita, you're on mute.
Okay, sorry. So welcome everybody to this session. In this session, we'll talk about KubeEdge, which is a Kubernetes native system framework for edge computing, where the idea is to extend cloud and the cloud capabilities to the edge side. So I am Harshita Sharma, software developer at Kubernetes. I have been talking about this topic since the beginning of this year. Had a few talks in different conferences like KubeCon and recently KCT Berlin. The agenda for today is first we'll start with overview of KubeEdge, brief introduction of what is KubeEdge and how is it different from other edge computing solutions we have in the open source community. Then we'll jump to the main design principle of KubeEdge, which is the separation of orchestration and computation. What this means is the control plane will be kept on the master nodes in the cloud, but the actual computation, the pods, the applications, and the devices will be kept on the edge side, which can be far away and much ideally closer to where the data is being processed, near to IoT devices, or for example, in case of traffic light, the edge node will be as near as possible to the traffic light system itself. Then we'll discuss on why the separation was required and why is it ideal for the synergy of cloud and edge. Then we'll discuss in KubeEdge how they are solving the challenges of having the orchestration far away in the cloud and computation on the edge side. Then we'll also jump into and try to discuss the communication between the cloud and edge. Okay, so what is KubeEdge? KubeEdge is an incubating project under CNCF. So it has a lot of support and popularity in the open source community. Overall, it provides the wholesome solution for managing devices, networking capabilities, and also syncing the metadata in the edge side so that the node autonomy can be achieved on the edge side, which means the edge nodes can work independently when the cloud and node communication is not there for a few minutes, for some time. The separation of orchestration and computation. So why the decision was made? Keeping the control plane nodes on the master side will be ideal, because on the edge side, the first limitation which you generally face is there's a limitation of resources on edge side. And the second thing, the main challenge is regarding the network limitations. So keeping in mind the network and resource limitations, The main orchestration, the control plane nodes, the K8s API server is kept on the cloud side, and the computation, keeping the decisions, computation near to the data being generated, or is kept on the edge side. Also, it gives a flexibility to meet different business scenarios, because in some case, all the computation doesn't need to be on the edge side. More complex and the time consuming one could be kept on the cloud side, but the simple ones which are needed immediately could be kept on the edge side. So this is the how we'll discuss in much more detail, and most part of this presentation contains the answer of this question, which is how the depth separation is being done and what challenges are being solved by keeping in mind that Kubernetes was designed uh, to to be run on data centers which have and it is scalable. So on cloud we have nodes in our hand. We can scale to increase the resources and add new nodes when required, but in terms of edge computing we have limited resources. So how to handle that? To have lightweight Kubernetes, a multiple new open source solutions are coming up. K3s is a famous one, which is a lightweight Kubernetes and only keeps the modules of Kubernetes which are required to run Kubernetes, not everything. Similar to that, KubeEdge also tries to minimize Kubernetes as much as possible, but because the control plane side is on cloud side, so no limitation or shrinking is made on that side. But because the kubelet, the node agents, work on edge side, so there has been reorganization of functional models of kubelet to achieve a lightweight system and keeping 70 MBs of memory to the edge side. So instead of requiring GBs of memory to run kubelet on different edge nodes, we can just work out with having 70 MBs. And because the Docker one also Docker container time also needs a lot of runtime resources. Containerd and CRIO is also been integrated for container runtime integration, so that minimal container runtime resources can be managed on the edge side. Next is clouds edge synergy. So in KubeEdge, the edge and cloud are not seen as separate components. More of it's seen, the edge is seen as an extension of cloud. So we have been using Kubernetes and cloud capabilities for scalable orchestration, running applications of distributed nodes. We'll keep it that way. The user will uh, use the kubectl command to deploy applications either on a hybrid cloud node and edge node system, or on just edge node systems based on the business requirements. But both will work in synergy in order to provide a complete solution for the edge computing. Third point is bidirectional communication. So this is important because the communication between edge and cloud, which ideally means the communication between KTS APIs and the edge nodes and devices, is kept bidirectional because this create update events need to be synced on the edge side, and the updates of the applications and devices need to be synced back to the cloud side to keep the state in etcd and to keep the KTS API server updated. So a WebSocket connection is established between cloud and edge, keeping a bidirectional communication. Fourth is edge node autonomy. This was the main concern. This was the main concern of a few of the attendees in the previous talks I gave, which was, do cloud and edge communication needs to be always there, and what happens if it's disconnected? To answer that question, edge node autonomy is achieved in KubeEdge. How is it done? I'll discuss in the further slides. But two things to notice. In in case of node recovery or in case of disconnection of cloud and edge communication. Uh, a local data store is kept on the edge node. For each edge node, there is a local cache kept, so that if the communication is not, the state of the devices and applications are there in locally. So don't need to the nodes don't need to communicate to the KTS API server to get the updates. They are close to edge side and kept locally in a local data store. Let's jump to the architecture. It's a bit complicated to the usual KTS systems we use, because the cloud and edge has been separated and a number of modules has been added to achieve this the whole working system of edge computing based on Kubernetes. But as the KubeEdge is based completely on Kubernetes, the devices are created and stored as CRDs, so it can be easily managed KTS native way. I'll briefly describe what each component is doing here. Let's start with the cloud side. We can see a clear demarcation between cloud and edge. As the edge generally works in private networks, so the communication is kept in detail in mind to create a system so that the cloud and edge communication works properly. Even if when edge is in private network, because businesses don't want to make their IPs public, don't want to send their data away from their systems to the cloud. So in the cloud side, you can see a green box, which is a KTS API server. No modules changes has been done there because we have enough resources in cloud ideally. So the KTS API server is there. Cloud core is the term I'm going to use here continuously, because the cloud core is a set of modules created by KubeEdge to run and integrate with the edge side. What it contains is it has controllers. It's an extension of Kubernetes controller, where the syncing of events happens from the cloud and edge. In the cloud core controllers, we can see edge controller. Edge controller, I'll discuss more in detail later on. But the main purpose of this is it's a bridge between KTS API server and the edge core. What this means is whenever a user creates or updates a KTS resource, the syncing of those events needs to be done on the edge nodes. For that, edge controller behaves as a bridge and keeps syncing those events to the edge side. Second thing which is needed to maintain a connection between cloud and edge is a WebSocket server. So the Cloud Hub here shown works as WebSocket server, and it helps in syncing the messages and events which are sent by edge controller to the edge side. What happens is edge controller keeps watching KTS API server, just like traditionally kubelet used to do. The controllers used to do from the different node size to keep update of new events. Similarly, to be able to watch and sync events from the KTS API server, the edge controller watches the KTS API server, and then the communication is being done using the WebSocket communication, where the server is kept on the cloud side called Cloud Hub. Now let's go to the edge side. We have Edge Hub, which works as a communication bridge between edge and cloud. It receives the events sent by Cloud Hub and then syncs those events to the node level data store. Node level data store is kept on each and every edge node. And how this happens is when Edge Hub receives events, It communicates with a meta manager, which is a message manager in KubeEdge, which communicates with edge plus synchronously also stores the states in node level data store, so that in case of this connection, the state is stored somewhere for the edge nodes to get the events, get the state of the application from. Edged is something which is important for us because edged is a lightweight kubelet. Whoever has worked on Kubernetes knows what is kubelet. So it is a lightweight version of it. I'll be going to use edged term a lot. So it's important to note that it is a event. It's an agent which runs on each and every edge node, and it is responsible for communicating with the container runtimes. Plus, also manages the application and config maps volumes deployment on the edge node. And there are a few components also created for specific to devices. For example, you can see a device controller on the edge side, on the cloud side, and you can see a device twin and event bus on the edge side. But today we'll not discuss much about how the device management is happening. But to give a brief overview of it, there's a MQTT setup kept on the edge side to be able to connect with the devices. Mosquito server is deployed on the edge nodes, where the publish subscribe communications happen between the node and the devices. So who is the client subscribes themselves to this Mosquito server. Whenever some events happens, the sub, whenever a device publishes an event, the clients who have subscribed to those events get those events. Don't worry about questions. I'll take all the questions at the end of this webinar. Let's continue with the architecture. So I described what the cloud components and modules are there on the cloud side and the edge components on the edge side. In this picture, you can also see edge core, which contains multiple nodes, container runtimes integrated with applications running. And you can also see one important thing is the edge is when you see the pods here, the pod to pod communication is maintained using edge mesh. To briefly describe how this works is edge mesh is kept on each edge node, and pod services are created to be able to communicate, have a communication between pod to pod, application to application. And so for this, generally now how this works is the nodes, edge nodes need to be on the same subnet. But in future, it will be possible to have this communication between applications to applications across edge and cloud. For example, if you have an edge, you have an application on cloud node and you have an application on edge node, the communication is currently not possible. But the KubeEdge team is working on it to make the communication thorough. So what you will need a router on the edge side to be able to communicate, and we'll have edge mesh on the nodes, on the cloud node and the edge node, so that the applications can communicate. So it's work in progress, but the same subnet edge nodes, application to application communication is possible using edge mesh. So I have described in brief what is Meta Manager, which is a message processor between edged, which is the lightweight kubelet, and it is also and the edge hub, basically what the events which are sent from the cloud to the cloud hub and then to edge hub are synced into the data store and to the edged using the Meta Manager. The lightweight database which we are using on each edge node is SQLite. Next is edge controller, which is a very important component in cloud side. I have described a bit how it works. So basically, it's an extension of Kubernetes controller, which watches the KTS API server and syncs those events on the edge side, but also takes updates events from the edge side and syncs it back to the KTS API server. We have different controllers for that, for the upstream and downstream. We'll look into it later on. Event bus and device train are both focused on managing the devices. Uh, Today's target is not to discuss the device management and communication much, but as I mentioned, the MQTT server is kept, and the MQTT client interacts with the Mosquito on the publish subscribe basis. And device join is something which stores device status and syncs those back to the cloud. So let's come to the two main communication components, which is Cloud Hub and Edge Hub. As I mentioned, Cloud Hub is a WebSocket server which is responsible for watching any changes on the cloud side and caches and sends the messages on Edge Hub, which are ultimately sent to the edge and also stored in the local database, which is SQLite and KubeEdge case. Edge Hub is something which it works as a client. It receives the syncing messages from the cloud side, but also reports device status and host status to the cloud. So it's a bi-directional communication where the syncing of events and the updates happens in both the directions. Is the audio clear, or are everybody able
Yes,
to hear me?
I can hear you. You can continue.
Meeta?
I can hear you. You can continue.
Okay. Now, Edge Hub. So Edge Hub is responsible for the communication between the cloud and edge. Let's go in detail on how and what protocols are supported currently. Either we can have WebSocket connection or a quick protocol, but today I'll discuss about the WebSocket connections. So the syncing of events happens because in the both directions. So let's talk about the route to cloud from edge. We have different modules working on the edge and cloud. So the communication between different modules and the edge happens using a beehive framework, which is a Golang based Go channel based communication framework, which happens between different Go modules which are subscribed to a particular group. So edge components and modules like Meta Manager, Event Bus receives the message. Sends the message to the Edge Hub about the new updates and the status and health. And those events then are sent through a WebSocket connection to the cloud. And when it comes to route to edge, all the events, create events, update event, delete events, which are received by Edge Hub, are then communicated to different edge modules using the beehive framework. It not only syncs the events, but also runs the keep alive to continuously check if the cloud and edge communication is there, and keeps informing the edge modules about the communication status. Okay, so I have been using this term a lot, which is edged. It's a lightweight kubelet. The kubelet modules originally kept in Kubernetes were reorganized to make it a lightweight one. So the basic functionality of kubelet is kept in place. It communicates with the different container runtime interfaces. The user can use kubelet as usual to deploy applications, and the management of pod lifecycle is done similar to kubelet on edge nodes. In case of a communication breakage or a node recovery, what happens is traditionally, if a node fails or is trying to recover, again a list of list watch events need to happen to the KTS API server, because the node needs to know what is the current status of the applications. But in this case, which is KubeEdge, the list watch is not required, because the state of the application is stored on each edge node in a lightweight database. So when it comes to edge controller, two controllers are kept, which is downstream one and an upstream one. As the name suggests, the downstream one syncs, update, delete, and add events to the edge. And also, so how does it is watches the KTS API server and sends all those updates and events to the edge code via Cloud Hub. Upstream controller sends the events from the edge code side, and the updates of the applications already deployed are sent from the edge code to the cloud side using this upstream controller, and then are synced to the KTS API server. To give a brief overview of how the setup works is, on the cloud side, you need to have a control plane node, obviously, and there only edge controller will work, which is which need to have a HTTP connection with KTS API server to be able to watch KTS API server and sync the events. So for that, what you can do is edit the API server YAML file to have that insecure port, which is 8080, and bind it to the address of localhost, so that on the same localhost we can run the edge controller module, and then the edge controller is able to establish a connection as HTTP connection to the KTS API server. Now, as your control plane node is working and functioning, and we have made the changes for the edge controller to communicate with the control plane. Now we can set up and clone the base code of edge and cloud using the KubeEdge Git repository, and you can then set the co-part too. When the base code is cloned on both edge and cloud, we can start generating certificates which are required to have a communication between the cloud and edge. So the script for creating these certificates are already kept in the KubeEdge repository. You can use them to create certificates on the cloud side, and then you can copy these certificates from the cloud and edge, because they both can be used on cloud and edge. So once you create the certificates on cloud side and you verify that they are created properly, what you can do is if you have a SSH connection, then use the SCP command to copy these certificates to the edge side. And what happens is these certificates are then used in SAN to have a secure connection between cloud and edge. Once you have copied the certificate to the edge node, you can go back to the cloud node, and then you can start building and running the cloud modules, whose scripts and setup scripts are already there on the KubeEdge repository. Then next step would be if verifying that if the cloud modules are running on the cloud side, the next step would be deploying an edge node. Similar to what happens in the Kubernetes is, if you want to attach a worker node to the Kubernetes, you need to create the node and try to communicate with the cloud core system. And when the registration of the node is done, the node is attached to the cloud, and it can be seen in a proper edge node or a worker node in Kubernetes. For that, what we do is, if you want to change the name of the node, you can do it using editing that node.json, and then you can use a simple kubectl command to apply that. What is needed is, if you have if you need to communicate with the cloud core IP for that, and because we have already set up the cloud core, then we can communicate on the 8080 port. But if you don't want to do that, you can have the kubeconfig file saved on the edge node. In that case, you don't need to specify every time using in the kubectl command the IP and the port to communicate with the KTS API server. You can just use the kubeconfig as usual to run the kubectl commands. Next would be, if you want to run an edge node in containers, you need to have Docker as a prerequisite setup on the edge node, and then you can go into that KubeEdge repository, go inside build and edge directories, and then run this script called run-daemon.sh. You need to provide your MQTT port and the cloud core IP. MQTT is required to have the connection between devices at the edge core. So the MQTT needs to be set up in the edge core. I'll provide a few links, and if you go to the KubeEdge documentation, you can see how the MQTT could be set up in the edge nodes. The port which needs to be open on the edge node is 188.3 for the MQTT to work properly. So once you have provided the IP and the port of MQTT, next you need to provide the Cloud Hub IP and port. The Cloud Hub, which is the collection of modules which is running on the cloud side, you generally uses the port mentioned 1000 on the cloud side, and so this means that this port should be open on the cloud side, so that the communication can be established to the Cloud Hub from the edge side. Then you can provide a dynamic name to the edge node, and the image of the edge core is provided because we are running this in the Docker, so we are providing the image and the container name. It's not necessary to run edge nodes on containers, but this is something, if you want to have a trial setup or for testing purposes, you can try to have an edge node in containers and see if it's being connected to the cloud side. And the next two obvious steps would be check the status of the node. If it's ready, then you can start deploying your application on the edge node. A question which was asked by me by another attendee was, what if do you need to make any changes on the general deployment YAML to be able to deploy it on the edge nodes? The answer is no, you don't need to. But if you want the applications to run in a particular edge node, you can just provide a node selector in the node.json or node.yaml file, and so that the application will be run on that edge node. KADM is something which is very useful to set up the KubeEdge components to avoid editing a lot of configuration files and deploying a lot of prerequisite software. What you can use is KADM, KubeEdge native software installation software for KubeEdge. What it does, it checks if the prerequisites are available on the cloud and edge side, and if not, it installs the prerequisites. For example, on the edge side, it will install the MQTT, etc., MQTT Docker, etc. And then you can use KADM to set up the cloud and edge components, and then ultimately try to join the nodes to the cloud side. The three commands which are most useful for that would be KADM init, which is used to bootstrap the KubeEdge cloud components. This command will be run on the cloud side. Then to bootstrap edge components, you need to run KADM join on the edge side. You need to provide cloud core IPs to this command to be able to make a connection to the cloud core, and you can also provide the edge node name. This command will not only start the edge component but will also help to connect an edge node to the cloud. One thing to note here is to be able to connect an edge node, it can be done manually or automatically. There is a configuration file where you can set up that if the edge components are running on a particular node, that node will be automatically tried to be registered on the cloud side. And if you want to manually do it by running the kubectl command, then we have both the options to do it, either using the kubectl or automatically. Third would be if we want to clean up the processes running on edge or cloud side, you can just use the kadm reset command. And if run on the cloud side, it will clear the cloud processes, and if run on the edge side, it will clear the edge. Prerequisite would be Docker to run this. Currently, KADM only supports Ubuntu and CentOS, and Raspberry Pi support is in progress. So if you want to try it, you can use it on Ubuntu or CentOS. And if you don't have either of these OSs, you can just try to the manual configuration all the steps are mentioned in the KubeEdge documentation. I just briefly described today that what basic steps are required to do that. One thing to note here is to be able to run KEADM, because it installs softwares, it runs processes, it needs to be run as root user. Thank you. Here are some resources. So the first one is the GitHub repository of Kube1. Second is the doc, where you can find the installation options too. In the third link, I provided the URL for the setup of KEADM. And the fourth one is our Kubernetes GitHub repository. You can try to communicate using Kubernetes Twitter, or if you want to check out the Kube1 project, you can check out the docs or the GitHub repository. They also have a Slack channel. Sorry, I didn't provide the link here, but you can communicate with me on Twitter, and if you have any questions, you can ping me there. I have mentioned the Twitter account in the initial slides. It is _I Harshita. So let's jump to the questions now. Meeta, can you tell me the questions?
Hi. So as of now, there aren't any questions. If anyone has any questions, you can still continue to write here in the Q&A. If not, you can always reach out to us or Harshita, as she mentioned.